My name's Steve and I love people who make things.
You might need to take off your trousers, and we see...
A number of times people have asked me to take off my trousers in a workshop hand. They sit at the heart of our communities, spreading wealth across the country.
I look forward to Mondays.
I love Mondays too.
And I'm going to die here. I'm never going to retire.
The isolation is great, no crowds apart from the tourists and sheep.
And the occasional podcaster like me. Sorry about that.
Yeah.
These are uncertain economic times. Keep our manufacturers alive and we'll thrive.
We all learn how to do everything here because there's so few of us left.
It is becoming a little harder to get young kids out of college that want to get their hands dirty and learn some of these very traditional art forms.
Join me as we compile a list of the greatest items made in the UK and hear stories from inside our factories.
My father has a phrase, he said, you should plan like you're going to live forever and live like you're going to die tomorrow, which I think is a very good way of looking at it.
We need you to live much longer than that, Martin. Welcome to the factory next door and welcome to the Buckinghamshire countryside. You, me and a lot of red kites. We are looking down over a selection of warehouses, a real mix, some kind of 1960s brick, corrugated iron, some very modern looking warehouses. Now, figuratively speaking, it's taken us a long time to get here. If you remember, last year we were in Surrey hanging out with the wonderful team from SSTL who make space satellites. Now, I was chatting to Andrew from there. I was asking about what kind of companies he works with around the UK. And he casually mentioned there's a team making rocket engines which they test in concrete buildings before shipping around the world. And I was like, I say what now? That is a factory you and I need to get invited to have a look around. So I'm going to pop down there now, sign in at reception. Whilst I do that, you have a listen to what's coming up on today's show.
I guess I've always been interested in space.
That is 1 for humanity, 0 for the machines.
I think engineering is incredibly creative.
Get me in this car right now. Wow, 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 this is an extraordinary room.
It's actually surprising how many places in the solar system we've been to.
Do you talk to yourself and kind of rehearse in your mind how you would cope with it failing? Okay, we're about to see these students fire their rocket.
12, 11, 10.
Good luck, everyone.
8, 7, 6.
Oh my word, look at that!
Ian Coxhill, I'm the chief engineer here.
Okay, Ian, super excited to be here. Where are we? What are we looking at?
Okay, so we're looking at the manufacturing area of the Nammo UK facility. So you can see various machine tools which are used to make the rocket components, which eventually end up in the clean room, precision cleaned and assembled into the actual rocket engines and systems that we make here.
Tell me a little about these machines here. So we're looking at quite a number of kind of machines, lots of them modern.
Yeah, so we have got some modern CNC machines which are super new. They've only been here a couple of years. But we've also got a mix of older machines, because older machines aren't necessarily any worse. Some of the manual operations that we do actually demand the old non-automated techniques, so we can get the actual feel and precision to it. There is a degree of craftsmanship which go into making these engines.
Oh, this is fascinating. So when I was coming over here, driving over here through the lovely Buckinghamshire countryside, I was thinking, I wonder how much of making a rocket engine is these days is automated, is down to computers and robots. And what's fascinating, literally fascinating, and you've just been talking about it there, is the number of what I would regard as kind of old-fashioned machines dotted around here. There is literally vices and lathes on workbenches.
Absolutely, yes. There's no getting away from the fact that this is a manual operation. And you've also got to recognise we don't make thousands of units per year. We make items in the hundreds or sometimes in the tens. So we're not high production in terms of volume, but we're high production in terms of value. The micro hole driller, which we're going to go and take a look at soon, we did actually try and automate that process a few years back, and we did get several companies to try and do the micro precision drilling for us. and they failed. They were snapping drill bits left, right and centre. They were unable to meet the accuracy or indeed the reliability that we needed to make our rocket injector elements. So we actually went back to using the hand method to do it because it was in fact better.
You tried to automate
Yes, we tried
an
to
element
automate
of
it.
your manufacturing process, and actually you couldn't do it, so you went back to hand.
Yes.
The human eye and hand.
Yes, because a human's got feel to it. You can actually feel the drilling process, and that feedback into the operator is crucial for enabling that drill bit to remain running true and to be able to cut accurately. So yes, we went back to using the Mark 1 eyeball and the manual operation.
That is 1 for humanity, 0 for the machines.
Yes, maybe AI is not going to take over just yet. After the Second World War, the UK government decided that they wanted to get into pretty much this rocket propulsion business. They saw it as the future, and obviously had a military side to it, and very much this was set up as a military organisation. So 1946 came along, and that was really the birth of British rocketry as we know it. And it's probably a little known fact that there were some German scientists that worked here. So everyone remembers the American scientists like Werner von Braun, who went to the US, and the Russians managed to capture their portion. But there were a few which came to the UK, and they pretty much achieved pretty high ranking status within this organisation and started the whole process. Over the years, the military side kind of waxed and waned, and it was kind of split between the liquid rocket engines and also the solid rocket motors. Both were vying technologies for military's, kind of interests. The liquid rocket engines, if you trace it all the way through, eventually became us.
These days, I mean, it is very much, it's a company, isn't it?
Absolutely.
It's a company.
Yes. I mean, effectively, we became a commercial rocket engine company in the 1980s. So, yeah, we've been commercial now for 45 years. So this is the best view of the clean room.
Oh, I see. Here we go. Okay, we've walked down just to the side, and there's a load of large windows, and we can look into the clean room.
Yeah, so what you're looking at here is our brand new clean room, and you can see we've got a lot of space, we've got stainless steel benches, we've got a lot of equipment, we've got computer monitors for data acquisition, we've got panels which are used for generating high pressure gases.
Sorry to interrupt, there's a guy just coming in now on our left, I can see, and he was just having to put on a lot of clean equipment there, the hairnet, the beard net, the coat.
That's right. So that's the standard clean room equipment, and you can see Lewis just walking in right now. He's got clean room shoes on, and it looks like today, because he's been wearing shorts, he's got over trousers on, because you can't walk into a clean room with skin on show. Because in fact, the worst item you can take into a clean room is exposed skin. So we like to keep as much of the exposed skin covered up as possible. So I know it sounds gross, but rubbing your skin generates flakes. That's debris, that's foreign object debris, which can get into the precision injectors, the valves, anything which has got fine holes in it is a problem. So that's the reason why we get dressed up with all the clean room equipment, to stop that, the human, I guess, scales from skin actually getting into any of the equipment.
Down with shorts.
Yes, I'm afraid shorts are not allowed in here.
And what happens in here then? So some of the pieces will have been made next door, and they come in here. And what are your colleagues doing here?
Okay, so this is really the final assembly. So our components are bought in, and they are taking those components, they are precision cleaning those components in the various stations which you can see around, and they are assembling it into either an engine, a propulsion system, or a valve, depending on which object we're working on, which product we're working on. We do have welding capability in here. We're about to upgrade it with another electron beam welder. We do have what's called pipe TIG welding capability in here, which we use for making propulsion systems. So think of it as an assembly process, a clean room assembly process, where the output of the clean room is notionally the finished item. Fundamentally, this is mechanical engineering that we're doing here. Yes, it's precision mechanical engineering, but nonetheless, it's mechanical engineering. I guess I've always been interested in space growing up. Very interested in it. Played with model rockets, when I was a teenager, probably younger than that, thinking about it. I was always interested in science and technology. At one point, I have to say, I liked the idea of being an artist at one point, but my career path didn't go that way. I chose not to do A-level art and instead ended up doing maths, chemistry and physics at A-level. That then put me on a trajectory which basically said, okay, I'm clearly sciencey based. What am I going to do next? I applied to do a degree in physics, so not engineering, but physics with space science and technology at the University of Leicester. Again, the space science bit interested me. So then I started applying for PhDs as almost a conversion process into engineering.
I love the fact that you've got artist or rocket engineer.
Yeah, I wouldn't say it was an either or, but certainly something. Let's face it, when you select your A-levels, you don't know what you want to do with your life. You do what you're interested in doing. And I was interested in art. I was also interested in science. And in the end, my, teachers convinced me to drop the art and do the science instead.
Do you think you can bring some creativity to your work, though?
I think engineering is incredibly creative. We are not following a single process. Yes, there are processes to which we must obey in order to get a successful design, but the creative spark, that's more akin to art than it is engineering. You need to have that visualization. You need to have the inspiration on coming up with something new. So at the fundamental level, there really isn't that much difference. You need to have that inspiration to make something work, and that comes from within.
Hi, I want to quickly jump in here because I am delighted to say that our show has a new partner, and one with a long history of helping manufacturers optimize their operations. AVEVA is a leader in industrial intelligence. It was founded almost 50 years ago in Cambridge. Today, its software connects and empowers people to improve plant productivity, sustainability, business agility. And if you're interested in manufacturing, which I'm guessing you are if you're hanging out with me, AVEVA's got a newsletter. Do sign up for it. Go to www.aveva.com/factory. I'll put the link in the show notes. My thanks to AVEVA for supporting the factory next door and for supporting our makers.
I want to introduce you to Harry. He's an apprentice of ours.
Hello, Harry. Nice to speak to you. How are you doing?
I'm good. How are you?
Yeah, very good. Thank you. Very good, Harry. Harry, what do you do here?
So I will generally do, anything the workshop guys are doing. So they could come in and ask for a new bit of hardware or a new bit of tooling. But it ranges anywhere from milling, turning. I do a bit of CNC on this lathe as well. There's a whole range of stuff that I have to do.
What kind of apprenticeship were you after? What was calling to you?
I was looking for something probably manufacturing based, like I'm doing here. So I'm a very practical person. I very much enjoy doing things rather than classroom learning, I'd say. So I get on very well by figuring things out rather than being taught something.
Is the apprenticeship working in this workshop here? Is it what you expected it to be?
You sort of come into it expecting quite a lot of instruction. What surprised me is how independent it is. Now, I quite like that because it means I can figure things out and I can learn. And obviously I do ask questions as well if I can't figure something out. But it's putting me in a very good place.
Harry, thanks for chatting to me.
Very welcome, thank you.
Let's be honest, that's the reason why you're here, because rockets are cool.
Rockets are indeed very cool.
Oh, look, just before we go, I recognise a beautiful engine there.
So yes, that what you've picked up on there is the Leros 4 engine. Now, Leros 4 is an engine which is particularly dear to my heart in that I spent quite a lot of my career actually working with a team to develop that engine. And what you see there in front of you is a prototype of the Leros 4 engine. And that was the engine which preceded the recent engine which we delivered to Firefly Blue Ghost mission, which actually landed onto the moon. Sat on the moon since March the 2nd this year when it successfully landed as part of the Blue Ghost lunar lander mission.
Many, many congratulations on that. Just describe that engine to me.
Yeah, okay. So what you see there is an object which is about meter tall, and it's approximately 0.4 meters diameter at the largest point. It's cone-shaped. It's got a grey combustion chamber which is relatively small. You're looking around about like 60 millimeters diameter combustion chamber, which then flares out to a much bigger expansion cone.
It is a beautiful, beautiful cone. I mean, from the exterior, not knowing anything about it, it looks extraordinarily simple.
Yes, it is. And at the heart of all our Apogee engines, and this is an Apogee engine, it is a very simple design. And there's good reason for that. We don't want any moving parts of the design. We want it to be as simple as possible because we're striving for the ultimate reliability. If something is very simple, fewest number of moving parts, it tends to be extremely reliable. Now, the devil's in the detail. The actual exact contour of that expansion cone is very not complex, but it requires a lot of computational power to design the optimum contour there. So even though it looks very simple, there's a huge amount of detail which goes off inside that to realize what you have as the final configuration.
Who are your customers? Who are you selling to?
Yeah, so see, that's quite an interesting question because up until recently, an awful lot of our core customer base was actually US, not European. So if you look back to early 2000s up to probably more like 2015, 2020 kind of territory, we were selling a lot of stuff into the US. We still do so, but we're also selling a lot into the European market now. But yeah, it's interesting that the likes of, say, NASA are quite happy to buy critical rocket engines for their interplanetary space probes from a small little outfit in the leafy corner of Buckinghamshire.
Do you ever tire of kind of saying to people, oh, what do I do? Oh, I make rockets.
Do I tire of it? No, I don't. I have had a funny story where I was asked about, what do you do? I'm a satellite engineer. I described it as because I thought that might be easier to accept than say rocket scientist or rocket engineer. And they actually asked me, could I come around and fix their Sky TV dish? And it's like, yeah, okay, we've got the wrong end of this. I'm the satellite bit, not the ground bit. But yeah, quite amusing.
Did you volunteer?
No, I politely declined because I'm not that fond of ladders, interestingly enough. This is my car here.
Oh, nice car.
So we're going to go up to the test site just to see basically how we test rocket engines, because we talked about the clean room stuff, and to be honest, that stuff, there are lots of businesses in the UK and in the world that do a similar kind of manufacturing process, clean room process, but what makes us unique is our ability to test rocket engines in simulated space conditions. So what you're about to see is test facilities that can maintain the vacuum of space whilst we're firing rocket engines. So if we get in the car now, we can go up and see it.
I cannot wait. Get me in this car right now.
So yeah, we're just going to pull up on the left-hand side. Now we actually are on a test site called J-Site, and J-Site is a series of 4 individual test sites, J1 through J4, of which J1 and J2 we lease out to a company called Airborne Engineering. Airborne are actually running a competition this week called Race for Space, where they get student teams in to test their rocket engines. So yeah, if we're lucky today, we might even hear one of the student teams testing one of their rocket engines, which is quite a fun thing to see and do.
It's a great thing to do as a student, blimey.
Yeah, it really is quite a thing that the UK Space Agency is helping with.
Okay, in the glorious sunshine in the Buckinghamshire countryside, we're in the test facility, and as you were saying, you've got the four different test buildings here.
Yeah.
Describe them to me. They're a unique They've got a unique look about them. Give me the
Yes.
estate agent talk.
Yes, I think unique is the charitable way of describing it. They are very much a functional-looking building. They look more like a concrete bunker. Is probably the best way of describing it. All four are pretty much the same and built to the same standard. Where, if I describe what I'm looking at, there's a control room on the back of the test cell, which we're about to walk into. Further behind that control room is the actual test area where the engine gets tested, and either side, in additional kind of concrete blockhouses, is where the propellants are located. The propellants we use are highly energetic, therefore we don't want the two propellants to meet until they really need to, which is inside the rocket engine itself, and that's why we keep the two propellants as far as possible up until the point they meet.
Okay, let's have a look in one of these.
So we're going to go into the control room of J3 first of all.
Oh, it is exactly what you would expect a space control room to look like. It's just a bank of computer screens.
Yeah, so welcome to the control room. So this is where our operators sit whilst they are firing their rocket engines. Now, I just make it clear that our rockets don't go off into space or anything. This is all static testing. So the operator is operating the control system to allow the engines to be operated inside the vacuum cell, which is the other side of this wall behind the monitors. And we're going to go around there and take a look at that very shortly. But yeah, the operators sit here, and the bank of monitors tell them visual indication of what the engine looks like. There's thermal infrared cameras pointing at the engine so we can measure the actual temperature the engines are running at. Typically our engines run at about 1,350 degrees C, so extremely hot. There's not much margin there. About 1,450 would be the absolute red line limit for some of the engines. So we use those thermal IR cameras to know a precise temperature to make sure we're not exceeding limits.
And then on the table, I love this, on the table is a giant big red button.
There is, yes. So that's not the firing button, that's the emergency stop button. So if during a firing we see an anomaly, the operator, and you presses it like so, and that automatically initiates a shutdown. The engines are so valuable, we can't afford the engines to be tested in a way which could cause themselves damage. So it's always better to abort and look at the data afterwards than it is to continue with a potentially problematic firing.
Hi, my name's Leo and my dad is Steve, host of this show. People often don't realise he does the factory next door all by himself. The recording, the editing, even the illustrations on Instagram. He's mildly talented, but he still needs a large amount of external validation. I guess as he grows up, he'll learn to be more self-confident like me. But until then, it'd be great if you could star the show on Apple or Spotify. Maybe even leave a nice review. Thanks! I'll let you get back to the show now.
Okay, so we're going to go round this way.
So we're walking around to the front, or should I say the back, of the testing facility. Oh my word, look at that! It's like a huge spaceship on this, laid out on its side.
So we will talk about what we call the diffuser system in a second, and what's called the plume intercooler. But we'll talk about the test cell itself first. So if you come in here, Steve.
Okay. Wow. Wow, wow, wow. This is an extraordinary room.
So what you're looking at here is a vacuum chamber, which is separated along its joint line. It all sits on rails, so the back part of the vacuum cell can be winched away to expose the inners of the vacuum cell, which is where the thrust stand sits.
So it's like a huge cylinder, but really, I mean, that is thick metal cylinder that you can roll out and split in two. And you put the engine inside it?
That's right, yes, absolutely. I mean, the engine would fit onto the thrust stand, and then we obviously tighten the bolts,
close it up. But
yeah,
then tell me, because I'm not very smart. You seal it in there.
Yes.
How do you then recreate the vacuum of space in that cylinder?
Yes, well, first of all, it's create a good seal. So you can see there's no ring seal on this flange here, which joins onto the other guy there. And bolts jaw, you can see the bolt holes between the two flanges. That's creates the seal by putting the bolts through. And at that point, when we've got a good seal, we can start the vacuum pumps. Think of it as, effectively a series of Henry Hoovers on steroids. Only these Henry Hoovers draw 3/4 of a megawatt of power when they're running. So they are spinning furiously, they're pulling all the gases out, and that pulls the vacuum cell down to about 1 to 2 millibar, which is the equivalent to about 140,000 feet altitude. So like an airliner, for instance, would fly at about 35,000 feet. We're creating the equivalent as if you went up 140,000 feet. And that's enough to simulate the equivalent conditions of true space.
The putting the engine in this cylinder, sealing it up, recreating the conditions of space, and then hitting the go button.
Yes.
That's got to be the highlight of your job, right? What a rush.
Absolutely, it is. And certainly when we first built this facility and the first time we ran it up, and by the way, there's no real way of going halfway to this. It's all got to work at the right time in the right place. And everyone who is involved in the development of the test cell, I think, will never forget the day we actually ran the system up, and it worked. And it worked first time, and it ran beautifully. We were extremely excited about it. I think now it's become mundane, because
This can't be mundane. Just look around us, Ian. There's pipes and tubes and extraordinary things all around us.
And I think it takes visits like yourself to come back here to remind us of what we do is extremely impressive and extremely cool, I have to say.
Do you let yourself think about how you would handle the failure? Do you kind of talk to yourself and kind of rehearse in your mind how you would cope with it failing? Or do you simply not allow that to enter at all?
I think it depends very much on your personality. I'm very much a realist, and there's many different components from the rocket engine and many different ways that it could fail. So you can't help but think, have I tightened that up? Is this injector working as it should do? Have I got the right pressure drop across this? Now, obviously, when an engine leaves the ground, you know absolutely for sure that everything is correct. That still doesn't stop your mind wandering into the slightly irrational side and wondering what's going to happen should it fail. There are also many parts of the feed system, and that's the propellant tanks, the pressurization system, the tubing which feed propellant to the engine, that's out of your control. So it's a bit like, for instance, on a car engine, say a fuel filter might block up. That's not the engine's fault. It's the fuel filter which has caught the debris from contaminated, say, petrol, which has caused that engine to fail. So you have to be realistic that there are many ways which something can fail, and it's not necessarily down to you that could happen. So of course you rehearse in your head what you might say. Yes, it's not a nice thought, but it's a grown-up approach to it, I guess. Are you about to do a firing line? Yes. Yeah. So this is the Race for Space competition that we were talking about earlier. And which university team is it this time, Ed?
Durham in J2, Edinburgh in J1.
Okay. Hello.
Hello. Okay, we're about to see these students fire their rocket.
So literally just through there, you can see just through the window.
Through that tiny little kind of letterbox pane of glass that's on the other side of that.
And that's bulletproof glass, you can see.
Okay, well, good luck, everyone.
15, 14, 13, 12, 11, 10, 9, 8, 7, 6.
Short firing. Now, that was a bit more unstable than we would have liked it to have been, but nonetheless, that's a good data point to enable them to research their injector and optimise it.
So you were instantly kind of like slightly unstable. Obviously, I didn't recognise anything other than a huge engine
Yes.
firing. What did you spot there when you were watching it go?
You could hear a tone. You could hear a frequency to the plume. So what you should hear is just a complete white noise, but you didn't. You heard a defined actual frequency in the tone. And this is for years of listening to rocket engines. You did pick up these, but that was work in progress. But the nice thing about it is the engine's still in one piece, so they've got hardware to iterate with, as opposed to a destroyed engine, which obviously would be a problem.
Well, congratulations, Durham University students.
Absolutely.
Unfulfilled ambitions. You've got one of your engines sat on the lunar surface.
Yeah.
Maybe Mars. I don't know. What other unfulfilled ambitions do you have?
Well, you see that there are many unfulfilled ambitions, but Mars isn't one of them. We have gone to Mars. We've gone to Mars several times. Mars Global Surveyor in the 1990s used one of our engines. The Mars Odyssey mission, that also used one of our engines. So we've been there. We've been to Mercury. Mercury Messenger used one of our engines. We've even landed on an asteroid, Eros, using the Eros 1 engine to land on it. So it's actually surprising how many places in the solar system we've been to. There's always something new. There's always something around the corner. And it isn't necessarily a kind of like gee whiz aspect, but it's a very interesting engineering problem. And that's, I guess, fulfills my ambitions, is to solve interesting engineering problems, hopefully space related. So yeah, and there's no end of those problems to solve. So ambitions have yet to be fulfilled.
I love you used to get those, well, you still get those kind of maps you put on the wall of the world, and you scrape off little foil when you've been to the different country. Do you have one of those with the solar system?
No, but maybe we should do. We really should have that. That'd be quite a fun thing to have, I think.
Ian, it's been an absolute pleasure looking around your factory and meeting your colleagues. Many congratulations on all that you are doing here. Thank you very much.
You're very welcome, Steve.
Okay, into our shed of greatness goes the rocket engine by Nammo UK. Huge thanks to Ian and the team for chatting with us, and thanks to everyone for the messages on Instagram, including Victoria Burnett. Very, very kind words. Zoe Jackson, nice house. Sally Kershaw, I like the suggestion. Let's all hang out again in 2 weeks' time. For now, wherever you are, whatever you're doing, I hope you're happy. Until next time, bye. My thanks again to our new partner, AVEVA. They're such a good fit for the show because they're in the business of helping manufacturers, and they've been doing it for more than 50 years. A leader in industrial intelligence, AVEVA's software connects and empowers people to improve plant productivity, sustainability, and business agility. Just a reminder that AVEVA's got a newsletter, and if you're interested in manufacturing, please do sign up for it. Go to www.aveva.com/factory. Again, I'm going to put the link in the show notes. My thanks to AVEVA for supporting the factory next door.